You guys have button press?
All right, I think we got everything working. Maybe I gotta mute. You guys got quiet way too fast. So my name is Chris. Thank you all for coming. We're gonna have some presentations tonight of a variety of things. And one from Shira remotely will be joining us from a ways away. At any rate, these are like show and tell style presentations. I think there's 4 or 5 people-ish. We're gonna let Dave go first. He's got the most complicated thing to set up. So at any rate, and then afterwards we'll jump around the room. You can say who you are or what you're interested in, and then I can give a tour if anybody's interested in seeing the shop. Go from there. So without further ado,
that's me, sir.
Jesus, Brian. One down.
Am I up?
Aliens coming. You're fine.
I'm Dave. Hi, Dave. All right, good deal. I've only presented one at a time, so if this is too much information, like grab the shepherd's hook and pull me aside. But I've got a couple of sun-based projects that I kind of took on both as a lark. This one takes a little bit of introduction. So I've got and this is a segue. I've got a lovely piece of property on the western part of the state. I'm kind of an avid but really crappy fly fisherman. And so one of the questions when we leave here in Madison is, am I going to get to there with enough time to fish? Because fishing's kind of best in the evening. And there's an app for that, right? So I've got a what times is the sunset app. Blessedly, I have no reception on my land, which is really nice. Every time I go there, it's like I look at my phone and please folk, no bars, no bars, no bars. And so far, that's good. So my wife and I were talking and be like, okay, we should like figure out like maybe just print out a sheet of paper with what time the sun rises and sets every day and just keep that there. And that struck me as something that was really unevocative. So I spent some time thinking about, wouldn't it be kind of fun to do a kinesthetic sculpture that showed what time the sun rose and sun set. This ended up being a gift from my wife. So I'm gonna pass it around. If you break it, that's cool because it's kind of a whimsical thing anyway. So this was the result of it. I will pass it around and you can play with it. The basic premise is that it's kind of kinematics. Which of these things? This is my screen here. So this little dial thing here rotates and the donut represents an entire year. And the donut has 3 different colors on it. White is when the sun is up. Black is when it's night, and the gray band in the middle is twilight, either twilight in the morning and twilight at the end. And the way in which this thing works is you set this date. I've only got the month of October on this, so you can spin it around to the day of the year. In this case, it's November 20th. And then you look at the bottom and you say that on November 20th, the sunrise will be about 7 o'clock. I'm sorry, twilight will start about 7 o'clock. The sun will officially rise at about 7:30. And then the sun will set at about 4:45. That's crappy, right? That time of year is always really awful. And then it gets totally dark at about 5:15. And so you can see as you spin it around, the days getting longer over here in the, the month of June, when the days get really long, the donut's long. These little kind of scallops there are daylight savings time, right, where everything takes a hit. So to do this was kind of a lot of fun. I had a lot of help and suggestions from people on how to do it. Jerry, who isn't here, was really useful because I don't have a lot of 3D printing experience. He helped introduce me to like what sizes to make things in proportions and colors. And Chris, as usual, was invaluable in everything, including originally I tried to make the numbers and letters embossed in the 3D model, and Chris said, oh, just make that as a laser cut part, which I think is frankly more attractive and made the part and model a lot easier to do. But let's see, I can't see because my screen is there. And so for those of you, this is kind of what it looked like, the final end up version. Those are laser cut chunks that are inset into 3D printed parts. There's the globe, a base, there's a little bearing that spins on. It's kind of fun, and I it's not the most useful thing in the world, but I think it's fun and it's kind of whimsical. It was fun technically as well. So what I did is I found a website where you can type in your zip code and it lists for every day of the year those 3: when twilight starts, sunrise, sunset, twilight end, how long the day is. I converted that in Google Sheets into like what each day was in terms of what angle that would be around the perimeter. And then I changed twilight start and sunrise and sunset into a percentage of the day. Minimize that so I can see right as I said. And then converted those into angles. And then in Google Sheets, I plotted that. And one of the cool things about Google Sheets is you can curve fit in Google Sheets. And so a third order polynomial was a pretty good approximation because the sun is kind of nice and elliptical. So a third order polynomial is within a couple of minutes, which that thing's nowhere near that accurate. And it gives you this fancy equation. And kind of a theme for me is I've been using a lot of Onshape lately. If you guys aren't familiar with Onshape, it's a 3D CAD modeling program that has the distinction of having a free version, which appeals to me. And it's totally cloud-based. And they open it up free so long as you're willing to put your models online, which I'm totally willing to do. And so one of the really cool things about it is that they've opened up the program with a utility called FeatureScript, which is actually an API. Well, it's not really an API, but it's kind of an API. They basically have given you access to the code so you can write your own routines. And so I wrote a routine to basically create a 3D spline, that polar kind of funky curve from those equations. I basically took the equations out of the sunrise globe. Here's the coefficients for the polynomials, the first, second, third degree for twilight start, sunrise, sunset, and twilight end. And then you could literally create your own features and functions. They give you the access to all, you can do everything. They basically have opened up the entire toolkit to you. And so consequently then you can write these little routines. And I wrote this routine called 3D points from an equation, and you execute and it plotted those curves that then I can sweep around the globe and make that work. So this unfortunately, it only works for Madison, Wisconsin. And so it has a total market of 0, like almost everything I do, but it was super fun and I had a lot of fun with it. So I thought I would share it. That's that. Yes.
So how many fish is this?
I'm a really abysmal trout fisherman, but I love where trout live. It's really beautiful. So it's kind of fun. And yeah. Yes.
Yeah, so you lost me with your no, that was my question was gonna be how you plotted on this curve. And I guess my simple question is, did you choose the size and the diameter? Does any of that matter? I mean, obviously it's all the scale up and down, but the relationship between the outer diameter and the curve of the diameter of the actual donut.
Yeah, so it took a little bit of I just spent some time thinking about how could I possibly manifest this thing, and the idea of kind of a donut came to my mind, where it's like, okay, white on the top and black on the bottom, and that kind of makes sense. So once I knew the donut, I knew the diameter I could, and actually that's what Jerry helped me with, because originally it was a little bit bigger than the size of a typical 3D printer, particularly one that can print color. And so I kind of fit it to the right size. Figured how big my wife was willing to put something on her desk. That was a factor as well. And then once I knew the size of the donut, then everything kind of all fell into place, right? So if you slice, in fact, let me do that real super quick here. I'll just grab arbitrarily a plane here, and I'll cut the donut in half so you can sort of see. At least I'll try to anyway. So there I've cut the donut in half. It's be a little bit easier to see kind of the black part and the white part. And then you can see in this particular case, I oriented kind of arbitrarily like 4:45 p.m. straight up and down. And that was sort of so I could get the most visible light. That was kind of arbitrary. Originally, I had 12 o'clock straight up and down. Then it turns out like almost everything is on the inside of the donut where you can't really see anything. It's not incredibly useful, right? Because you kind of got to peer underneath it to see it. But so then it was a little bit of trial and error to kind of get it. Like when I first tried it, it was like, oh, that's not going to work. I'm not really going to be able to see that at all. But kind of played around with it. And I was a month late for my wife's birthday too. As I also was like, Jim, yeah, man. That's the notches. Yeah. So that right there, you can see that's actually 1 day. And if you spin it around here, you can oh shoot. If you look at daylight savings time is roughly indicated on that. And that's another thing that makes this approximate is daylight savings time is always on a Sunday, right? So this clock isn't strictly correct around daylight savings time. It sort of shows that, you know, line right there, which is about the right day, but it could be plus or minus 3 days depending on, you know, what day falls on a Sunday. And so this is 2024. You know, it's accurate on 2024, and 2025 it'll be off by a day.
How many times did you print this?
The globe once, but Jerry printed it once for me too, because it was like a 26-hour print.
Print this, Jerry printed 3 times.
Oh, he did? Okay. Yeah, I owe Jerry beer. And I also printed out, or Chris was incredibly kind and helped me laser cut the little base. And then I looked and realized that on there I've like put when the vernal equinox is, and the equinox is when 12 hours days, 12 hours a night, which is kind of fun. And the solstice, the summer solstice, longest day, the winter solstice, shortest day. And I had a typo, and actually every one of those 4, instead of being each one, they all said winter solstice because I'd done a copy and paste. And it wasn't until I laser cut that at much effort for Chris that it realized that was wrong. So he redid that as well.
So code you did for Onshape.
Yeah, it's like JavaScript.
Yeah, not that you'll ever do this, but is that flexible enough where in theory you can go back and edit your model to let somebody type in the latitude and longitude and it would generate? Or is it not
That's equation fits their thumb. Sheets.
Yeah, that would not work, but that, like, if I had, I bet you could write a feature script that would do that, you know, because the solar world operates according to physics, right? So I'm pretty sure that if you were so inclined with a week and a couple of 6-packs of beer and a lot of coffee, you could probably figure out how to do I mean, people have written some amazing feature scripts. They've literally opened up the entire API of the program. So anything that the program can do, you've got access to, which is really fun. And I'm not very good at JavaScript, and I was still able to kind of plow my way through it.
I mean, because your center, right, that doesn't change. Really, literally, you're just changing the scale.
Yeah, but I think the further, we were talking about this earlier, the farther north you move, the longer the days get. So it's, yeah. So it's a little bit more complicated than, which is literally why that thing only works, I think, in Madison, Wisconsin. I mean, it would work at this latitude, like let's say our latitude, like Seattle, Missoula, Montana, right? It would work in those, but you'd have to shift the bottom dial. And then for the latitude and longitude, things get long. I've never given this much thought to sunrise, sunset before. Pardon me? Westby, Wisconsin, and it's in the driftless region. It's almost the exact same latitude. So, but it's like maybe 10 or 10 minutes off, maybe for the duration. It's close enough. Yeah. I mean, look at the things plus or minus what.
You want to do your other?
Yeah, so it was embarrassing. This is Chris who pointed out that both of my presentations are solar themed.
Maybe had glasses, sunglasses. Now with the microphone.
Oh, it's not that bright. So this is another guys, fun thing I'll share. So a friend of mine, Chad Sorensen, owns SunPeak, which is a solar installation company here in town. Speak very highly. They only do commercial work, so not good residential work. They've stopped doing residential work. And he actually, his sister works there as the marketing director. I've known Chad for a while. Super good guy, really good guy. And they had won a contract to do a really cool solar installation on the roof of the parking structure at the new hospital on East Park. If you've been over to the east side by East Mall, American Center Parkway, there's a UW hospital, East Park going up, and they did a solar installation on top of the roof of the parking structure, which is really cool. So, you know, they had to do a lot of work on like water remediation, how to deal with water coming off of it. So it's really pretty cool. And the UW is very proud of it. And April 12th, they were commissioning it because it was Earth Day. The hospital itself, I don't think opens for like a couple months or something like that. Anyway, so he called me up and he said, hey, we would really like to commission this. Can you think of something we could do, like the giant scissors you use to cut, like, or the shovel when you dig up? And I thought, well, yeah, that'd be kind of a fun project. So we got together and spent some time just brainstorming on what could we do that would allow you to commission a solar installation. And the idea we came up with was if there was this giant switch that you threw that caused a meter to swing open, that and I think a lot of the people who saw it really thought we were literally like throwing a switch and powering the solar. Maybe not, I don't know. But, so it was just kind of classic design. We brainstorming sessions. We kind of threw out ideas, did a lot of sketching, kind of came up with this rough idea, and then decided, oh my gosh, we've got to try to build this giant switch and this giant meter here, which I'll just sort of demonstrate. It's supposed to look kind of coppery. And this sort of sits like this, and then when at a certain point in time you flip that, nothing happens when you do that behind the curtain. So push this button, and the meter kind of swings up. Oh yeah, sure.
Oh, you're good. It's all right.
And it lights up and does that. Sorry, it's a little bright.
Yeah. Wasn't getting on the sunglasses.
So yeah, and let's see, I can share maybe just a little bit about what I learned from this. The first thing is I've absolutely fallen in love with the 3D router here, much to Chris's chagrin. He taught me how to use the 3D router, which is like the most amazing and super cool tool. I've got a little bit of a CNC background, but I've never had access to something kind of this big. And I found it kind of unintimidating and really valuable. And one of the real challenges with this, I didn't really know how do we make this giant meter? And the idea I came up with was to make it a medium density fiber board, MDF, if anybody's used that, really cheap. Machines, and I wasn't sure this was going to work, so that had kind of appeal. Machines sort of inexpensively. So you kind of detect the theme here. I'm getting better and better over time at using SolidWorks. And I designed it in SolidWorks and split it up into various panels, and then generally used the 3D router to kind of panelize it like that. One of the things that was sort of interesting, and Chris warned me about this, the thickness here that has this sort of band of stainless steel around there is actually pink styrofoam. And I asked Chris, can I cut pink styrofoam on the router? And he said, yes, you can cut pink styrofoam, but you have to clean the router when you're done. And he said that with much wisdom in his mind, because when you cut the pink styrofoam, it creates static electricity, it gets everywhere. And literally, I think I spent 3 hours cleaning the router, and I was using the router earlier today. And I made this thing like 4 months ago, and there's still pink styrofoam everywhere on it. So lesson learned if you want to use pink styrofoam. But you can see here's the kind of the knife switch itself taking effect. There's the thing sort of coming together. Chris also introduced me to this really cool thing called NeoPixels. If anybody is not familiar with that, they're a programmable LED. So I was thinking, oh, you're going to have to like individually wire to all these LEDs or write some sort of a multiplexing circuit, which I know the word, but don't know how to do. And it turns out that somebody has created addressable strings of LEDs that you can run with an Arduino, and it's like really freaking simple to say, turn on LED 5 and make it blue, and turn on LED 7 and make it green, or something like that. Originally, when I demonstrated this for the marketing people at SunPeak, I wanted to demonstrate all the cool things the NeoPixels could do. And so there's chasing sequences, and then it got rainbowy, and it got all sorts of, and they basically said, nah, Dave, we're just going to do blue. But the NeoPixels do all that super cool stuff. So I thought that was kind of fascinating. And then it's run by an Arduino. Yeah, so the back of this thing is, and that was, Chris gave me a stepper motor, which I think is an old Tormach stepper motor, if I'm not mistaken. Bought a cheap stepper driver off of eBay, a couple of power supplies off of eBay, an Arduino, and it's sort of wired up, a couple of, wired an aluminum panel, and then I, programmed it. And I will talk, if I've got a couple of minutes, I want to talk about programming it, because that's kind of a fun story. I'll share something that might be kind of cool. So here's some pictures of the event. It was covered by a whole bunch of news networks. There was a whole bunch of people there. You can see the installation there, which I think is, like I said, really cool, because they have water management, and all the solar panels are angled in a particular way. It's really, really kind of something to be proud of, I think, for the city of Madison, the fact that they did that. I probably can't do audio here, can I? Yeah, it's probably not with it. That's okay. So anyway, this is the luminaries. I don't even know who they were. I think the president of the hospital throwing the switch. Krista Lobmeyer, who's their marketing manager in the background, has got the little yellow remote. So they throw the switch and she pushed the button and it swung over and everybody cheered. And then it got to the end and it lit up and everybody cheered more, which was really, really fun. And I tell you, I was so freaking nervous. I was just waiting for it to like kind of defibrillate or do, you know, kind of, well, yeah, exactly. But it worked really well. And they were super excited. So Chad lent us this thing to, it's the property of SunPeak, but he said, oh yeah, it'd be awesome to show it to the folks at Sector. So one thing, the last thing I kind of wanted to show, you know, and if anybody, the schematic capture, doing the electronics is not exactly my forte. I would love to learn a little bit more about a decent schematic capture program. The folks at Autodesk used to have Eagle, but they've kind of discontinued that. So if anybody's a wizard at that, I would love to learn a little bit more because I'm a mechanical engineer. So all this stuff is a little bit vague to me. But one of the things that was amazing and has it kind of a little bit of a double-edged sword is I used ChatGPT to help write the code for this. Has anybody used ChatGPT to write code? Any hands here? Okay, a couple people have raised their hands. I was going to do a super quick demonstration of the power of ChatGPT, which I think is kind of just to show you kind of what's going on with this, kind of amazing. I say double-edged sword. I'm not a horrible programmer, and my wife has worried that AI will make us intellectually lazy. And I think that's a definite risk because it got to the point where it was kind of late at night. It's like, okay, I could write a routine to turn this on, but let me just have ChatGPT do that. And then like the day before this was going to occur, Chad said, could you make a modification to the program to do it this? And I couldn't do it, you know, because I didn't really deeply understand the program. But I thought I would sort of demonstrate sort of what its power and capabilities of, or try anyway. So let's see, here is the Arduino program that I wrote, or the ChatGPT wrote. So I'm going to copy this and I'm going to dump this into Chat and ChatGPT. I'm going to say here, please reference the, and I'm going to misspell it, the following program for some questions. Let's see if it's good enough. And I'm going to just hit paste. Oops, that's not, that's a picture. Let's go back to, yeah, see what that does.
I think the screen isn't quite active. Yeah.
Copy that. This is a really bad idea, doing a demonstration in front of a whole bunch of people. We'll see what it's okay. So we hit that and it's going to come here and it's going to say, hopefully, like, sure, I can help with that. What specific questions do you have, right? Okay, I'm going to try doing this with voice typing. We'll see if this works. My friend Chris has told me that he thinks this program might be more interesting if instead of smoothly going from 0 to 100%, it would jitter upwards from 0 to 100%, period. In other words, it might go up a little bit and then backtrack a little bit and then go up more to make it seem more like the power was kind of oscillating as it came online, period. Could you please help modify this program to add some jittering to it? Make sure that the needle never goes negative. I'm gonna hit go. Certainly. And here's the program. Now, how's that for a mind screw, right?
The compile, it actually surprisingly, Dave, had very little swearing after doing these things multiple times.
Yeah, I want to be respectful of other people's times. We could try this, and my guess is it wouldn't do exactly what we thought it would do, but it would probably be pretty close, and I'd have to come back and say, oh, not quite exactly what we were looking for. That's either really powerful or really terrifying, depending on your perspective. And like I said,
I see jitter stuff. Oh, it's at least trying.
yeah, oh yeah, jitter step, current step, and so it's create a routine here, and we can even say, let's just say, well, here I can voice type. Can you describe what you did so I can better understand it? Oh, let's try it. Just have to be in the box. Can you describe what you did so I can better understand it? It's gotten cranky on me. Yeah, the thing of it is, it's unfailingly polite. Like, it'll say, certainly, you know, this is what I did. I'm guessing it probably added a random number generator in there somewhere. There's probably a new program called Jitter Step. For those of you who are pixels, motor step. I'm not seeing it here, but I would suspect there's probably a jitter in here where it's basically probably creating a random number, and depending on random number, it's either backing up or going forward. And you know, so like I said, I thought it was pretty amazing. Like it knows JavaScript, it knows, well, this is kind of Arduino C, right? Which is like a version of C++ or something like that. And it's, you know, kind of amazing as a mechanical engineer. It's also a little bit of a crutch, right? Because if I, for those of you who are computer savvy, had I written this myself, I would have used interrupts. It wrote it as a state machine. And so when Chad said, could you make this, you know, easy, what seemed like a really easy modification, I would have had to go back and totally gut the code, and I didn't really know how to do that. So I wasn't able to implement exactly what we wanted. So it, like I said, it's amazing, it's terrifying, it's really, really cool, but also really, really scary at the same time.
You did the delta or compare, would it be clear that it's modifying the code, or is it just generating something new?
No, this is, I would be disappointed that here. Let's see if I can.
It's going in and editing. I mean, it's not like it's adding on a thing at the bottom.
That's my understanding is it doesn't. Maybe I'm wrong. You know what I'm getting at, right? So if you gave that to a programmer, they would start with your code and make changes.
Yeah.
My understanding is generative stuff is just generating what makes sense. It's not going and doing edit.
No, this is actually editing, and so it will build off the current code. So it has not thrown away the current code. That has been my experience.
So it alters everything.
Not ever, it'll only make select alterations. It starts with the code I have, which is, I would bet the new code is 90%. So here, this is even more terrifying. I said, can you compare this code to the previous code? What changed? Now it's even giving me, like, it's trying to learn from me, like, which response do you prefer, right? And here's a comparison of the changes made in the original code to add their jitter effect, and there's certainly, it's always so unfailingly polite. So it either tells you the original code or here are the changes. So it changed the rotate stepper and update perimeter lights function. It introduced a current step variable used to keep track of the current position. You can read what it's done. It added a while loop for the needle movement. So it basically took that original code and added on to it.
And it can tell you.
Yeah, totally. And this is, I guess this is what well, first things, my analogy, I tell my wife, I think as a mechanical engineer, AI is like the equivalent of the lever. Like when we invented the lever, it's the force multiplier. AI is like an intellectual lever in my mind. But it's like having a really smart person sitting next to you. They're not always right. Sometimes they're full of shit. Sometimes they're wrong. But it's like having a really smart person next to you can bounce questions off of. Sorry. I should watch my language. I apologize.
Any other questions?
Any question? Yeah.
So, I mean, phenomenal project, but I have to ask, was it a conscious choice or intentional choice not to connect the levers actually?
It was, yeah.
I mean, obviously that would have been all the things you did, like, just
The lever was originally connected to the device, but we were just worried that the whole point of this was a little bit of theater. And we were just worried that somebody would go up there and bump it or run into it.
It's actually showing generative capacity and it's all cloudy, and you're going to move the needle
Oh,
3%.
I'm sorry. Should we really connect it to the solar installation? No, he said connect it to the lever.
Oh, no.
Yeah, because that was the original intent. Because it was here. And the other thing that was a little bit, okay, it's very humid out. If it's super dry, this thing will be really close to dropping. So,
I'm gonna get solvable problems.
Yeah.
You could put friction at the point.
Oh, that's why it works. It's friction.
yeah.
No, so Dave did hook up. I mean, you hooked up a switch to it. Or
Yeah, the original intent was I really wanted them to throw this and actually actuate it. And then the more I thought about it, the more I thought that's just adding a degree of stress. You know, switch fails, if somebody bumps it, if it drops, something like that. So I mean, it would have been very straightforward, but we literally there's like a 30-foot cord to this yellow push button. And so the marketing director, Krista, was like way in the background where people couldn't see her.
Oh, so you were just hiding in the crowd?
No, I was not. I was in the background praying, right? So super fun. Learned so much things for a lot of these things. Once again, I'll belabor my thanks to Chris with a lot of grief for me because I'm always using things the way they're not intended to be used. But he taught me how to use a lot of cool things. I learned some fun things. And if any of this has any appeal to anybody, if anybody would like that light into share in more detail what I learned.
So are they gonna at least use this for every single solar?
Yep.
company?
Yep, this will get repurposed and then the back comes off. I actually argued that they should put the UW logo on there and they finally decided now they just keep their own logo. The back comes off and you can just print it and logo up and want it for a different client. They'll use this kind of in every solar installation. Launching.
Have you programmed in like the circuit overload?
What's the Easter egg? Is there Easter eggs in here or what?
Yeah,
Like
yeah.
a horse in there or something like that? Thank you, Dave. Thank you, yeah.
Oh, you're fine. Shira, do you want to go next? I don't know what your time looks like.
Yeah, I can try 1 second.
All right. Dave, you want to undo your screen share? No. Otherwise, I can kill you off too, buddy. You'll have to, yeah, it's easier if you just do it. So I think I can kill you. Oh, there you go. I gotcha. Hi, Shira. I'm going to turn off your audio. a little bit.
Hello. Okay. Yes. And so if he's gonna let me, I will share my screen. Let me find out how I do that. Share screen. Oh, there it is. Okay. So do I have to put it in present mode? Slideshow. Center view? Nope, that's not it. Sorry. Okay, that should do it, right? All right, hey everyone, I'm Shira, and I live in Massachusetts now, but I deeply miss Sector67. Like, you know, I watch the mailing list, like where my my heart lives. It's a really cool. Like I keep thinking I gotta go back sometime. It meant a lot to me in the time I was there, and still means a lot. So I did a project recently because my cat started to lose a lot of weight. And also I have a baby, so I was like really nervous about giving my cat radioactive iodine, is basically the short version of it. So the start here, the cat in question, Katniss, she dropped quite precipitously in weight to like 65% of her top, like weight, and like 75% of what her ideal weight would be. And you could feel she was all like bones. And we tried Tapazole, and she had like developed non-regenerative anemia from that. It was not, she could not go on that medicine anymore. It was going to hurt her like pretty badly. So our only remaining option was to give her the radioactive iodine treatment. But of course, with a baby in the house, it's like, is that a good idea? So we bought some sensors, like they're here. We bought 2 sensors, a Bluetooth radiation sensor by Aranet and like one of those Amazon Geiger counters. And the Geiger counter comes with a hilarious card that says that if the radiation level is above 0.65%, you should find out why. And if it's above 0.65 microsieverts per hour, and if it's above 6.5 microsieverts per hour, leave the area and find out why. And if it's above 13, you should report it to the government. I did not report my cat to the government, but I'll walk you through the data collection. And we did some, just like the first presenter, we did some curve fitting. And what else did we do in this project? We didn't do ChatGPT, but we did mash together Stack Overflow code. So it was like a fun little project here. So the radioactive iodine, which takes the form of sodium iodide, it basically selectively gets taken up by the thyroid, and then it destroys tumor cells. And hopefully we don't have a cat who's now a hypothyroid cat, but that's very fixable if it is. And it requires a 2-week quarantine after the procedure is done. But like, rather than just say 2 weeks, let's like, use data to decide when the quarantine should be over. Let's continue the presentation. So did some reading, and most people would get 10 millicurie, but a cat would get 3 to 4 millicurie based on like what Purdue's veterinary site said. And I could have probably asked them what they actually gave my cat, because they did dose it according to like her, weight and other things, but I forgot to ask. So I started to do some like estimations, like trust but verify. Like, is my cat radioactive, like in a way that you'd expect for the treatment that she got, or is it like really, really bad? So she came home like 2 or 3 days after the treatment, and I did some calculations based on some models I found in some NIH papers. because I wasn't really sure what model to use, and came up with some numbers, but the numbers themselves, yes, buddy, hi, are not that interesting. What's more interesting is like the inverse square relationship, because you can't really keep the cat at 1 meter from a sensor, and like so you're like reading these numbers, you're like, what does it mean? So this is just the car ride home. Again, I tried a couple different things. I placed it in the center console. The left is actually right after it was on her hard carrier, so it's like a lot higher than it was in the center console. I spent about 45 minutes in the car with her at this time, and at the end there at 5:30, it's when I got home and I put it back on her carrier, and you just get a sense of how the numbers just started to look. It's like beeping the whole time when you put it on her carrier. It's like certainly alarming. You're like, okay, this cat is really radioactive. So if you kind of do a couple calculations here, I came up with this table here. That at a half a meter, I'd expect 24 microsievert per hour, and at a quarter of a meter, I'd expect 96 microsievert per hour, and at about a centimeter, like right around her neck, I'd expect like 600 microsievert per hour. We measured 300 microsievert per hour right at her neck. So it's like, this is basically the behavior we saw. The closer you got to the cat, it goes up really quick. Let's see, what else is interesting to say about, okay, so the cat, we didn't want to strap the dosimeter to her, but like, you put her in this room, you close the door, and you're like, good, done. Like this wall, this door is magical. This is quarantine, but that's not exactly how it works. So underneath the room that she was in, so in the dining room downstairs, we were seeing like 5 microsievert per, sorry, not 0.5 microsievert per hour, which is like living in like a high altitude city like Denver. And then at the door, because she's always like really lonely, she wants to be let out. At the door, you see like 7 to 10 microsievert per hour, which the alarm on the Geiger counter goes off, and it's like starting to tell you to like get out of the zone, get out of your house. But it's not that bad, because if you were to take a flight, and next time I fly, I will take a Geiger counter with me, but turn that alarm off. You're gonna see like 5 microsievert per hour, or if you're like a really high altitude flight, you'll see like 10 microsievert per hour. So it's not like you can't spend some time in there, or like that a baby would not be recommended to spend time. It's not that bad. But we tried not to hang out in the hallway. She really would hang out like right in front of the door. And we had a Google Nest Cam, so I got some like great screenshots of her, but I also was able to monitor without having to go into there, which was very useful. So then we had this like question, which is like, does the door block anything? We didn't really do a ton of data collection on this one, but I read up that it's 90% beta emissions and 10% gamma. And while the beta particles will be blocked by, say, like a centimeter of plastic or 2 centimeters of tissue, the gamma ones might entirely pass through you and not even deposit any energy in you, or they might, it's hard to say. So we didn't really I think if we had another radioactive cat that needed, another cat that needed therapy like this, we would probably set up a test for this. But as such, there were enough data collection parts for this. So at that point, I kind of told some friends about it, and they're like, oh yeah, my mom had this therapy, my tutor had this therapy. And one thing that I noticed was like all the stories, all the patients were female. So I read up about that, and it turns out that's like 10 times more common in women. And I think that it's the same case for cats, right? Probably female cats have a much higher incidence of hyperthyroidism. So quarantine was, for the first 2 weeks. So there's a whole process. You put flushable litter in the box, and you take the litter, you scoop it, and then you put that in the toilet, because apparently the local dump will have sensors to monitor radiation, and they won't like it if you throw away radioactive material, because it is in part eliminated through urine and feces. But I guess the wastewater treatment plant doesn't care, which is interesting. We measured the bags basically. Like my husband would take a dog poop bag and scoop the scoopable litter into the dog poop bag, and then he would test it with the Geiger counter, and then he'd throw it down the toilet without the bag part, and test the rest of the residue of the bag, and then he'd throw that away if it wasn't radioactive, and then he would test his feet and his hands if they weren't radioactive, and then he'd wash his hands. So it's like this whole process, and you could see that the bags would kind of, slowly over time, they start to drop in how radioactive they were. But we also didn't really test that one particularly carefully. The majority of our data comes from the Bluetooth sensor, which sat in, actually I should go back, it sat right in this cat tree with her. So at least like once a day, she hangs out in that cat tree for a while, and often with her neck pressed up against the sensor, which means that you have this chance to really kind of get a sense of how radioactive she is at that day. But it's also that the sensor itself, its total dose is not equivalent to being strapped to her neck. Its total dose is equivalent to being in the room with her, right? Assuming she would spend some time near you and some time not near you. And at around day 18. At day 18, I was like, all right, should we take the cat out of quarantine? And this is the data at the end. It's a bit more obvious, like, you know, when it seems like the total dose isn't going up anymore, but it wasn't so obvious back then. So first I had to read some papers to figure out like what is like the model to use. And, you know, some papers basically say if you're talking about pharmacokinetics, you're going to always be talking about by exponential pretty much. And that seemed to be the case. The data kind of looked like that. Played around with Desmos, the coefficients, trying to get the right shape. And I was like, okay, this is probably the shape we're trying to fit based on the data that I'm seeing. And so I pulled up, you know, code snippets with SciPy. You know, didn't quite get to ChatGPT here. It's still faster for me to just kind of like grab some Stack Overflow stuff, you know, edit it. Basically, it wasn't as easy as it seemed, right? So this was the code that as it ended up, but also there was some pre-processing on the data. What happened at first is the predictor, it doesn't fit the right curve, and so the predictions are all off, right? This one predicted that we would have the world end very soon, and so I'm like, okay, like let's keep trying to plug away at this. So one of the things that so eventually I got the noisy data to kind of look right, but I just wasn't getting a sense that this was particularly like I wasn't willing to make a decision based on this. I didn't feel too confident in the curve fit. Like for example, on this one here on the total dose, which is not a by exponential. I just used SciPy's optimized curve fit. It like just didn't seem like it was flattening off fast enough in the model. And then on the left there, it's not capturing the peak, and so I'm not really, and it feels like it's dropping off too fast. So we kind of just waited to use our human brains to look at the data and decide to let the cat out. But then I kind of read the whole thing afterwards. So you have to kind of consider cat behavior, right? It's the noisy data. It represents a lot of time when she's not near the sensor at all. And sometimes she hangs out right on top of the sensor. So kind of intuitively, if you kind of look at the highest value you've ever seen, that's the one to look at up until you reach the first peak. And then you reset and you start looking again for the highest value that you've ever seen. And so each time you see the highest value you've ever seen, that's kind of when she's near the sensor at that point in time. And by reducing this down to essentially what's called like the Pareto frontier of the data, you know, it still wasn't like the most beautiful fit. I feel like it you know, didn't really capture that really sharp peak right at the beginning, but it's a bit more reasonable. Anyway, the most important thing at the end was to weigh her again. So this little red piece here is that she jumped up in that time from 7.5 pounds to 8.8 pounds, which is pretty crazy. She feels different. Like you look at her, you touch her, she's just a different cat. So that's really, really good. And that is her on her last day, like on the day we took her out of quarantine, we took her for a little walk around the yard. But yeah, now I have this like $90 radiation sensor that I have no other project for. I think I'll take it to the university, and maybe something at the university, you know, is not supposed to be, but is radioactive. I'll keep it in my office or walk around campus with it. And that's my presentation.
Maybe you have questions for Shira? If you speak loudly, she should be able to hear us.
So was the radioactive sensor just like on her neck the whole time, or was it on the...
It's in the cat tree, so once a day, more or less, she'll kind of curl up next to it.
Is there a way to put that like on like a collar size thing for him?
I'm sure you could, but like she would hate it. So you know, fighting with her about that, it just wasn't worth it, right? Like what you can solve with data analysis is always easier than what you can solve with like mechanical engineering.
And how much of your apartment glows in the dark?
So the good news is with the Geiger counter, we can find like messes, right? Like if she were to feed on the floor, we can know. So we can say, no, none of it glows in the dark. Though the non-radioactive pee that the other animals manage to leave on the floor does glow under UV light.
This is amazing and really cool. How does the protocol for human beings differ from the protocol for cats? Is the same issue present in human beings and people just ignore it?
There are different rules. You know, there's a lot of like considerations when you get to human beings, right? Like human beings, you might be a parent, right? Like, or you know, I'm a parent, but you might have a parent go through this where they kind of have to stay away from their children, which is really depending on the age of the child. Obviously, like a younger child, you don't want to expose them, but also you might need to care for them. So there's a lot of like different, you know, I don't really know the full. I only have like anecdotal information I got from people whose parents went through this, but there's something, right? You should. I don't know if they changed the dose up, or you know, I don't know if they just what they do, but you do have to use your own toilet. I think that was something that was a long time ago. That was a friend of mine who told me about her mom who had this done like in the 90s, so it may not be accurate.
Did you ever consider turning this into a protocol that, I mean, you did this out of care for your child and your cat, but this feels like a protocol that would legitimately be useful.
Right. Okay. So here's what I'm thinking. Like nowadays, these sensors are so cheap, and they've gotten cheap really recently. And so I think what's missing from like, I don't know. I've been reading a lot of medical papers, including like one. It was like measuring radiation levels in the hospital. It was like hallway, bathroom. Like these are categorical. Like you could just, why not? Like why is this not a graph with distance, right? Why is this not a map in 2 and 3 dimensions? And I think it's because like just a lot of this stuff is older papers, and nowadays like people don't realize that like yeah, for like $90 you can have this great data collection system. So maybe we should just go out there and redo some of these papers. It's just like this low-hanging fruit that like, you know, like it's so easy to make an embedded system that wirelessly you transmit data all the time in high resolution. It's super cheap, and it's like solar operated, or solar powered and battery operated. And it's just like there's so many cool data collection projects out there that like people should do. And the only reason they haven't is because I guess like the target audiences haven't realized that it's so cheap to do it now. Like they could make a protocol that when you bring your radioactive cat home, the therapy, it costs a lot of money. It costs $2,500 to treat your cat. So like what's $90? Like to have this just like a sensor so that you know that like it's all going well, right? Like they should just send everyone home with one.
That was my question. Did that suggest you quarantine your cat for X number of days, or was this something you just chose for your own?
It's just they tell everyone 2 weeks, right? Regardless of anything, they just say 2 weeks. And they don't have anything about the layout of your home. They don't inspect that for you, and they don't really advise you on it. They just tell you put your cat in a room, an extra bedroom if you have one. So like, because they're just trying to come up with a simple thing they can write down in one sentence on a piece of paper. But things are getting so easy to do nowadays. I feel like yeah, you could modify that protocol, especially for an expensive treatment like that.
So Shira, now that you have like a lead line cone for the cat, but could a plastic collar or something simple capture, a significant portion? I mean, you said at one point how thick the plastic had to be to absorb the radiation.
Wait. So to keep the cat in a 2 centimeter thick plastic bubble?
2 centimeters thick. Okay, I didn't hear that. I didn't hear how thick.
Yeah. I mean, you could put like a giant hamster ball. It'd be very thick though.
Awesome. I want to see that.
And there's air holes too.
Because
And the radiation would go through those.
But like just literally a lead line collar around the neck.
Well, I mean, you can't. I guess it might also come out her head. Like I don't know, like maybe it's like an astronaut.
No, just to manage some of the, and a code would limit it at least to a certain thing, and Sam has to look at.
Yeah, I mean, I think the room was pretty effective. Like on the first week, admittedly, we slept on the far side of our bed. It's a king size bed. There's a bit of a distance because the bedroom is right next to the other bedroom, and you could see the numbers go down. But it was really mild. It was like the difference between being in Denver, Colorado, and the difference between living in a lower altitude city. It was like on par with cosmic radiation in various places in the world.
Did you notice that your computing devices are a little less reliable that week? Little random memory errors.
There was a moment where the Nest camera, which was really close to her, was like really staticky looking, but that was just an auto exposure issue. I cannot tell. Yeah, there's no evidence that the Nest camera was damaged by spending 2 weeks in close quarters with the cat.
I'm sorry, I missed this, or I lost it. What did the sensor look like?
Oh, it's like a square, like a little square. I have one.
I got one here, sure, it's all right.
Yeah.
We'll try it on Aaron. He's been totally
That's the sensor?
stealing it.
So
I'm
that's not,
radioactive too.
Oh, here, I've got the Geiger counter. So the Geiger counter is like almost the same shape. It's like a handheld. Both of them are handheld sensors. They're like little square plastic boxes. The other one is Bluetooth logging.
so that the sensor itself is not miniaturized to the point where you could put it on the cat. You mentioned that, I think I missed.
No, I think the sensor you could. This was a project where I guess I don't know the answer to whether anyone would sell, like it's already selling on eBay, like Google search away, but whether somebody is actually selling a sensor for cats that would fit on a collar. Maybe. This one though, it was designed like for the home sensor, so it has a screen on it, an e-paper screen. And it's not, miniaturized, but it could be miniaturized. Like if you got rid of the screen and everything else, absolutely it could fit on a cat collar. But that's like an embedded systems project that's going to take like a couple months to develop, which I don't currently have the bandwidth for. But yeah, someone should and could do that.
Any other questions for Shira?
Just real quick, so if you put it next to the cat bowl, you would always have a good reference distance at that point? So in other words, you take a reading every time the cat came to eat?
Oh, yeah, so once a day, for example, Scott would bring the Geiger counter in and get a reading at her neck when he went to feed her. Yeah, because you go in there to like, once a day to spend a little bit of time in there.
Okay.
So you
It's-
certainly could do like a manual data collection where you go in and you measure at her neck and then you write it down, or hit a button and log into your phone. Yeah.
I gave Aaron a piece of 30 tungsten too for a TIG welding rod, so no big deal. He's just
More
been
radioactive
playing around with it.
I don't know why I'm more radioactive.
All right, thank you, Shira.
Jacob, you want to go next? You got the slides. Yeah, go. So this yep. Steal it from Shira. Angry baby. Okay. It's like a full screen mode. I don't use this software. Doesn't look like any of these is really right. Menu?
It's fine.
Yeah, it is. I guess it is okay. I wonder if
This is at the bottom.
well, this is fine. Okay, so anyway, hey folks, I'm Jacob. I do a lot of taking things out of my apartment garbage room and repairing them if they need to be repaired, and then sometimes people will buy them online or I'll give them away. So about like a year and a half ago, I got this. I think it was actually in the dumpster. So someone clearly decided that it was not not repairable, but it's like a bar stool. It's just a wooden seat and a metal frame, and it looks like the metal frame had somehow gotten ripped out of the seat. And I think I found a couple of the screws with it, but the screws had been like ripped out of the seat, so there were some big holes. And then it sat for a really long time, but I finally got around to fixing it. So that is the story I have today. First step here was, oh no, let's see. So I was the first step is figuring out how do I want to fix this. My first thought was this failed somehow, so maybe I want to fix it in a way that will reinforce it further to make sure it won't fail in the same way again. My idea for that was going to be to drill a couple of extra holes in that metal frame on each side. So say instead of 4 screws that it had originally, I could have 8, and maybe then the seat would do a better job of hanging onto the frame. But then I thought about drilling through metal, need like cutting fluid and a sharp bit, and like it takes forever. So I had talked to Chris about, do you figure it out? I just got to share your screen. Oh, it's a good thing you didn't let me get very far. That's good. It's all on the same slide. There you go. Yeah. Okay. So I asked Chris like for some advice on how you'd repair this, and if you're not cutting through the metal, it's basically just a matter of patching up that wood piece, and then you can put some new screws in. So pretty simple. And I guess what you do is either the cheap method is you put a bunch of like toothpicks, you fill these holes with toothpicks, and then you cut them flush, and you put wood glue in there, obviously to make sure they're seated. And the slightly more expensive method is you get like some dowel stock and then drill out to a known width and use a dowel to fill the holes. And I like the dowel method better, so I got like some 1/4-inch dowel. Some 1/4-inch dowel at the hardware store, and found a drill bit size that was like very slightly larger than that. Drilled out those 4 holes in the seat to the right size, and then the slide is showing cutting off some little sections of dowel to put in there. Then fill the hole with wood glue and stick the end of the dowel in there. So that's that's all 4 dowels in, and I cleaned up some of the excess glue there. Then leave that overnight for the glue to dry. Then I came back and this is the flush cut saw that we have at the space, which allows you to, it's like a flexible thing, so you can run it right along the surface and cut those dowels off so that they're pretty much flat with the rest of the surface. And then it looks like that. So obviously not exactly like it looked originally, but you've got a repaired surface that you can actually drill into. And then maybe kind of hard to see the difference here, but this is after drilling some pilot holes. So I plopped the frame back on there and sort of set it where I figured I'd want it, and then drilled holes. They're not quite centered in the dowels, so I think there was some kind of error, compared to where the original screws were. I'll skip ahead. Oh, not very far ahead. Yeah, so you can't really see that well, but it's like, it varies. The front is like probably like 1.5 inches thick or 2 inches or something. The back is a little bit more. So you don't have a whole lot of depth there. Well, and you have less also because it's inset. It's solid. Yeah, it's solid wood. It's like a couple of pieces glued together, I guess, but it's solid. So yeah, I drilled these pilot holes for the new screws. I put a little bit of thought into this because, like I mentioned, the back is thicker, so I wanted to get as long screws as possible to make it less likely that the same thing would happen again. So the pilot hole and the screw in the back are a little bit longer than the ones in the front. But yeah, then I just put the frame down and screwed the screws in, and yeah, like I showed you, that's what it looks like. It's a pretty nice looking stool, I would say. So retrospective on this, the one thing that I think I maybe should have thought about a little bit more is that I guess if I go back, you may be able to see that with this frame, the holes are kind of tapered. So it's meant to take like a flathead screw that has a taper under the head. And I didn't use that type of screw. I just used screws that have a flat bottom of the head and like a dome top. So it may be that the screws are not sitting as securely in those holes as they would be if I had like a tapered screw head, but I tightened them down and it seems like they're pretty sturdy. So no sledgehammering. I don't think so. So yeah, that's pretty much it. Any questions? Pretty straightforward, right? Yeah, Michael.
How much of a profit do you make on this?
Oh, well, actually, this one I do not currently have plans to sell because I think I can use it. I think it will be useful to have in my apartment.
The
So
price tag's still on it. If you can get that for it, get that.
yeah, $60. Right. Yeah.
Take it back to Marco today.
Oh, they're gonna gift card.
Yeah, I don't know how that would go, but yeah.
They're gonna deny it because it's not the original screws. Come on.
I would say that I could sort of answer that. Since I do this with a lot of stuff, I'll usually, again, it depends on the condition, but I'll often start things off at like half of the original price. So I would estimate that I might get like $30 for this if I sold it, which is pure profit. Yeah, I guess I spent $250 on the dowel or something, but well, yes, that's the big thing, right?
So behind Marshall's is a good place to shop.
Well, this isn't where I didn't find it behind Marshall's, but maybe.
You just wait until the rest of the set might come in the tray.
Are you saying there are a couple other stools that should go with it? Yeah. Yep.
What species of wood is the seat made of?
No idea. I'm not a wood person. Anyone know?
It's not IKEA.
I don't think it's in there.
Oh, it's not it doesn't look like any normal wood species.
So it's abnormal.
You're playing with threaded inserts.
Oh, that's an interesting idea. So you're talking about like a metal piece that I could put a machine screw in?
Yeah, so like if this is a carbon. Glue or epoxy, threaded insert that have wider threads on the outside, the grab.
There's
Mhm.
about 300 embedded inserts in that SunPeak meter. Yeah, everyone has agrees with me. I was wondering myself, but yeah, I mean, that's only because they need to remove multiple times, right?
Yeah.
Well, but it gives you a nice way to connect to the software.
Yeah.
Service area. Right, then you can just use it.
Right. I did think about that. I think the thing that stuck me was how do you attach the insert to the wood? And yeah, I mean, I suppose you could glue it
The
somehow.
rectangles, real bit is helpful, but it's soft. I mean, I don't think you need hard or soft or hard.
Right.
Just a little box.
Yeah.
I mean, you can modify the inserts, but they typically like that seven. But yeah, you can make it shorter because you don't need much break.
I've got a stack of them in the desk if anybody wants to see. Why do you think the screw stepped out in the first place?
Yeah, I don't know. I mean, like,
Well,
because you're just sitting on this, like, I don't know why that would. Yeah, I mean, like, the only thing I can think of is maybe it got knocked over like 100 times or something.
Well, if you found it in Wisconsin, there were a lot of Wisconsin butts on it, and that could be a lot of jostling.
Yeah. Okay. Yeah, Wisconsin butts. That's a better explanation, I think.
I come from Wisconsin.
Right. Yeah.
Yep.
Stop share. Right. One.
Baby's been learning astrophysics already and lockpicking, so.
Okay, that baby is already like beyond whatever I remember it was like in a Shira.
Are you hearing me fine? Is that working? All right. Okay. So what I'm doing is a study in a processor type called ESP32. It's kind of like an Arduino, but it has a Wi-Fi to it. So it has lots of pins. Here's like an example of one. This is one from SparkFun. And the main thing is sort of this big metal bit here. For a reference size, that's roughly what it is. So last month, I did a presentation on sort of taking information and sending it up to AWS Cloud through what's called an MQTT broker. Today, I am going to show off a couple things. One is someone made a nifty web server component that lives on these little things. And it serves up this web page, and then it sort of shows interactions of pins and LEDs and things like that. So on this one, I have the program on here, and I'll move this thing out of the way. All right. So here's the little program. So one thing that's kind of cool is it's kind of very responsive. So for one thing is there's like a little switch to turn the LED off and on. So if I click that button, you can see that blue light. It's going off and on. So what's happening here is this web server is talking to the sector Wi-Fi. I am then, through this IP address, talking to this device, right? And it's even like, you can see the things, there's analog pins here. So you can see me dragging, well, maybe I lost it. There we go, right? So it's very responsive, right? So it's using, for people who know web stuff, it's using something called AJAX to do that. And if we want to take a look at the code, it's relatively simple. It's kind of, so yes. So we'll gloss over it. We'll gloss over it a little bit. We won't go into everything here. There's kind of two main components. One is sort of the Arduino code. So one thing that's nice about the ESP32 is if you're familiar with Arduino stuff, it's a lot of stuff transfers over. So very simple. You sort of hook up you say what Wi-Fi you want to talk to. So here's a sector, and then there's a lot of these type of things, which is very similar. to normal Arduino stuff. There's again a setup and loop. And one thing you have to do is you create sort of the web server. So the web server is just you bring in a standard library. And it sort of turns on some pins. This is, there's some special things, but generally it sort of, you set it up and then you sort of listen on different endpoints, basically. And then it loops through, and every time an update happens, it applies that to the website. So the extra page here is basically all the HTML. So if you're familiar with HTML, it's kind of in here, right? So you can see like, oh, here's my thing, my title, all this CSS type of stuff. And then eventually you get down to, there's some JavaScript in here. Here we go, JavaScript, right? So it's using this like create HTML object. So what's kind of interesting about modern web page development is a lot of crap lives in your browser. So yes, right, exactly. So really it's just running this little snippet of JavaScript inside of this web browser, which then goes back into here. It responds by, depending on whatever it does, turn on the light, or this goes back the other way, listens out. So that's, oh, and now it's blinking all over the place. Oh, because what's also another thing is other people, so it's very simple. It's very, very simple, right? So there's no security. Anyone here can pull up that IP address and get it. So there's no security. So as that's this. So yes. So I mean, so that's the thing. There's like, in order to get to more modern stuff, you have to like, SSL, security things. Also, I have to log in. You give that client, on a session ID on this. Lots of other crazy web stuff. So you can go that route. Another thing that's kind of a down, you keep on building this web page too. You keep on, there's like 16 megs of stuff on here. So you could like load images on this thing and all that crap as it's loading the web page. The problem is, usually with people with embedded systems is this is limited resources and you want it to be very focused on a very simple task. And if it's spending all of its time serving up web pages and interacting with you, it's not doing other things like interacting with a motor, right? So if you think about driving a motor or even like the LED strip, you got to communicate at a certain rate to talk to it.
Yeah, so is this like your Arduino version of Flipper?
Kind of, yeah.
It's like an Arduino that's really tightly tied.
Yep.
So it's meant to work on internet. Arduino does a really bad job.
Right. So, but again, it's still limited. It can only do so much. You can't ask it to do a lot. So how do you build out from this? Well, what I did is I created a Raspberry Pi. I took a Raspberry Pi W, which is basically a Wi-Fi Raspberry Pi, and it's roughly the same size, right? So it's a quarter, and it's like right here. This is it right here. Okay. And what I did with this Raspberry Pi is it has a normal Wi-Fi connection to it. I put a second one on there. So the first one is talking to the internet, and the second one is an access point, right? So it's basically its own little Wi-Fi access point, just like your normal stuff. I've also put on there something called Mosquito, which is a publisher subscription service. So you can sort of subscribe and put little commands on there and pull it off, and you can have topics. I'll get into that more. And then the next thing is something called Node-RED, which helps me to sort of orchestrate between stuff. So what I did with this is create a second program that just talks via MQTT. So instead of this guy doing web server stuff, I have this one that it's just talking through Mosquito. So the only thing it's doing is listening to topics on this Mosquito server, and every time I put a command on there, it listens to that command on a topic and then reacts to it. So,
Chris knows you're doing.
well, I do all sorts of stuff. So, yes. So,
Sounds like it's on your network though.
right. So here is the node red that's on this Raspberry Pi, right? So I'm talking to this service here. So this is what node red looks like if you're not aware of it. So there's this topic called ESP32 output. So very simply, if I click this button, this will send a message and put it on this ESP32 output. So every time I click it, it should, there you go. You see that light? Turns it off and on, right? So what's happening is I am talking to the web server that's on the Raspberry Pi saying, hey, put this message out. This thing is also listening on the Raspberry Pi. Every time that gets a message, it then reacts depending on how I program, right? Does that, everyone follow? All right. So where can you go from here? So the next thing is, well, that's great. It works if I'm on the network. It'd be really nice if I could do it like through my phone or cellular or something, right? So the next thing was to use this service called Remote Red, okay? So what this is a, you can set up remote access. So I can set this up to talk to this server that's in America, right? There's ones all over the world. And you can then, it will set up, it'll go set up this secure tunnel. So it will talk to that server, create this. You can then take a picture, you can download a Node Red app on your phone and then talk to it. So in this case, it's talking to this UI. So I created a UI, here it is, right? So this UI is just like me hitting that other button. So if I hit the engage button, boop, 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 it turns off and on. I also do it with my phone, right? So I got the button on my phone, right? And this phone is off the Wi-Fi. I turned off my Wi-Fi on the phone, so this is cellular. So what's happening is this initially talks to that server, creates a remote tunnel, secure tunnel to this. Now I have the front end, which is coming straight off of this, and I can set a command through that. And that relays the command to any devices that are on that broker service, right? Why would someone do this? All right, so, yep, if you're not following, ask questions.
So you are those both?
Yes.
So I guess the question is, why can you do everything you're talking about? Too much. It's just too much.
Depends on what you want to do. Correct. So, right.
No, it's simply to expand memory.
Kind of. So the idea is, right? So the idea is, okay, how do I create a modular embedded system that kind of communicates through each other? So I can sort of program each one of these ESP32s to do a certain subsystem of a larger system. Let's say it's a robot or who knows what, right? So it has like, let's say there's like, again, I brought up my motor controller scenario. So you have one thing that just talks to one topic. So instead of me having this one topic that is, let's get done with this, that is ESP32 output, maybe it's ESP32 motor controller. So I put a command out there and say, move a little bit, right? And then all it does is it pulls that message off, says, great, I will drive my motor a little bit until I'm done. Similar thing with like user interface. So let's say I have like a series of buttons or things. I can then just program that ESP32. All it focuses on is user interface, looks at knobs, buttons, whatnot, sends that back up to this or either lights. And what's great about this sort of MQTT process is if I have something that's more resource intensive, like let's say I have another Raspberry Pi 0W, the camera on there that does like object detection, it can still talk through the MQTT to the cloud or whatever, but it can also, look at a picture and say, okay, run this model on it, this vision detection model. And when it gets up to here, to the Raspberry Pi with the node red, I use this as the orchestration of stuff. So like, for example, this is a method that someone made to basically update your Wi-Fi. So on this little front end here, like this is me setting the Wi-Fi on this Raspberry Pi. So this will go through and like, okay, when I hit scan, right, it sends a scan command to this, and you can almost see it step through. It's like, okay, scan it, figure out what my options are. Okay, what's the next thing? Okay, let me like change the password or whatever. And then when I hit the update button, there's the update button, and then like get the cat, and it does all the logic, right? So this is a methodology of sort of using like a web microservice architecture, doing a like embedded system microservice architecture that I can then sort of build more logic out individually without having to like recode everything, having one big main processor unit that does all the work, and let's say I make a motor controller system on something, and like I don't like it. Well, I can leave that one as, start over fresh, have it listen to those topics, and then operate in a new way, and then I can swap it out. And I don't have to worry about changing how my buttons work, my lights work, my image processing work, and things like that.
How far before you just go full on super?
Kind of paralleling the whole automation. And
Kind of.
Like a good way to think about it is that it's like automation brokering.
Yep.
Like message places and stuff.
Yep.
So there's a very similar parallel system to that where you're decentralizing a lot of control of a lot of devices. You're able to take in a lot of inputs simultaneously and then disseminate them throughout this.
And it manages like proceed queuing.
Yeah.
Yep. Well, this is like very simple. So this is just like you subscribe, listen message, put it out. If you're not there listening, when a message goes, tough luck, right? So it's very simple. It's almost like a hard. There's 3 types of embedded programming: hard, medium, and soft. So like soft is the data comes slow, medium's like, and hard is like, it better come now. If I don't have the information, I don't care. So there's other queuing methodologies that like want to do acts and nacks and that type of acknowledgements for everyone else. Like acknowledge, like you get a message, acknowledge things like that. So
Use that app for the second Wi-Fi?
it's just like a Raspberry Pi stuff. So the second Wi-Fi is just, you can find things online to say it's just this dongle. So like you get this little plug-in thumb drive. Yeah. And like, quite frankly, with the Raspberry Pi Zero, they got to the point now where you just go up and say, click, make hotspot. And then you put in your stuff and it makes a Wi-Fi hotspot.
It's really cool. One thing that I'm never sure of when I hear about these solutions. So is this targeted the hacker maker community? Is it robust enough for commercial applications, or would you be too dependent on infrastructure you couldn't necessarily trust?
Microsoft Grind.
Yeah. Well, so like the only thing that's sort of Node-RED is pretty well established and people commit to and contribute to and everything else. This remote red is kind of almost like go to my PC or something, right? It's kind of like a web server that's out there that allows you to connect to something.
It's pricing, so I'm assuming that it's sort of
Yeah, so like $6 for a year or something. What this thing? Possibly. It might be open source. I just got this working 2 days ago. So there is a thing in AWS where you can remote SSH in to the Raspberry Pi. I did look into that. So that was a more difficult version of doing that I have not interrogated. And I might not, because I found this and this, like, I mean, right. And like, so I can do all my coding through here, so to speak, right? Because like, if you look at what's in here, it's like, okay, little snippets, right? Of just like, this is just JavaScript that's just taking the results of something else, right? This thing was a pseudo command. So this is a command prompt thing. It spits out a result. That result goes here. That parser then parses it out. and then it goes into whatever, fills in this drop down list, right? So, and like there's a whole universe of like these nodes over here that allow you to do dashboard stuff, right? So this whole like there's like a joystick, right? So like if we take a look at, if we go back, we hit home, right? So this is like a joystick. So again, this is kind of like, okay, here's how I drive my motor, right? And if we look at it, this is the type of object that comes out, right? So there's like a vector and distance. So there's a distance that's like a certain distance. So you can set this up to like go this way or that way. And like if you wanted to change it, you could do things like, here's my joystick and say, I only want to, well, I could change a square and it's only vertical. Done, deploy. So if we sit over here, it recognizes it and it's like, all right, here we go. It's now a square. Oh, I can only go forward and backwards, right? So it's quick turnaround. There's built-in things that do what you need to do. I can do it on my phone. I don't have to do a lot of like architecture. Yes.
So the red app said like temperature, humidity, that. What did you actually? Like everything?
If whatever I build in, yeah.
You like you're just camera angles.
If I built the infrastructure for it, yeah. If I talk to it, right? So, but I mean, like it depends on things that talk to this Raspberry Pi. So I'd have to make this. I'd have to give it access to this, and then that relays any commands from either the web or my phone or whatever. Well, we're starting off with a robot, right? So we got lights, motor controller, user. 1 second.
Aaron, why you gotta wait for the big reveal?
I'm just asking a question. We're all thinking.
Get a motor.
That's what I was thinking too, man.
Get a motor controller. The motor controller can be driven off of what's called PWM.
Brian keeps asking where to find the Ryobi batteries.
Like, how bad could you fuck with
Right.
that stuff?
So this is a speed controller, right? So this sends out a PWM. So figure out how to find a Ryobi battery thing. You solder it together, right? You can then just put that in there. Pang, it turns on, and then it goes forward and backwards. So if I just put in my PWM to this, so there's no reason why I can't take the ESP32, instead of running shit off the battery, do a buck DC to DC converter, 5 volts from that thing, from the ESP32 to the ESP32, and then drive this.
How far under is the ESP?
How what?
How many power under is
Light, lighter than the motor.
it? You get like micros.
Yes. Right. But yeah, so that's the other thing too, is like I had to shut down one of the things to make the ESP as responsive as I wanted to. I needed to turn off. What did I turn off? There's here we go. Wi-Fi set sleep to false. So when I was first doing this, I was sending these commands to turn the LED off and on, and I would get one and then I'd miss it, or not miss it. They would come like sequentially. So the Wi-Fi was going to sleep, coming back alive, getting the commands, and then processing. So once I figured that out, then it became just like you saw at the phone. It's like almost instantaneous. So the next challenge will be, okay, if I have 2 ESP32s running two motors independently, is the bandwidth fast enough if I say, okay, turn on for 1 second, will it go straight or will it be like go like this way? So, because I don't know if there's a latency. Because like I said earlier, you don't necessarily want your microcontroller to spending all its time doing web server stuff when it should be driving motors and crap. So. Yep.
Is there case build your own server based on the same thing?
Yeah. So I mean, like, if this instance right here, this is me kind of again on the sector network talking to it. If you want to, you can go into MQTT server and talk directly to the Raspberry Pi. So I have different opportunities to cut down where the lag is. Yeah. So
No component in this.
nope. The Raspberry Pi is the most. That's the most operating system. Everything else, anything ESP32, this it's just this. It's just C, C, C++.
Look forward to the next update.
It'll be fun.
I think Aaron wants to see the robot.
Okay. Yep.
All right, I have a 2-second.
Oh,
Of course. Ouch. Brian, that's good for that. Oh. All right, I have a 2-second update on something amusing. So we got a bunch of stuff donated. So a while back I talked about building some particulate sensors, which actually dovetails very well into Brian's ESP32 talk, because these are ESP32 based controllers. And so these things are an open source particulate measurement system. So that's the same ESP32 Brian's talking about. And the only difference here is this thing's a particulate sensor, and this is a temperature, pressure, and humidity sensor. And so built a couple of these a long time ago, didn't have too much time to actually deploy them or do anything with them. Recently, we have 2 summer interns this summer. So we have a high school student and a college student that are going to be working on some projects like this. And so we had an opportunity to finish up these sensors. So we put one over across the street that's live on the network and is working. And we got some donations from East High School from their wood shop. And a bunch of them were really dusty. And so rather than bringing the really dusty stuff inside, we left them outside, blew them off with the air gun. This is like hundreds of feet in the wrong direction of the wind. And this was the particulate measurement reading of this thing, like spiking sky high, like the wildfire levels of soot, just from dusting off these things. So indeed it does work, which is good. And then interestingly, the other day, it rained really hard like it is now. And we actually could see a marked drop in particulate in the air from the rain cleaning the air. So it's kind of cool to see some real life data. The other thing then is so my ask, and I sent out an email earlier, and my ask was, we have a bunch of these sensors now, but what we don't have is a dashboard to be able to do anything with them. And so the question for you all, and maybe Brian, but Brian's probably too sophisticated for us, is that this data is published on this. There's an open source kind of charting system. This was Jeff in the welding shop earlier. So Jeff didn't turn on the exhaust system for like 5 minutes and ground some things. It's going to be like a new high score thing. So he got to 450. So the East High wood dust is like 80. 450 is pretty high. The good news is you can see this really sharp decay down. I'm not going to try to play the chart, really isn't meant to be interactive with, so I can't really zoom this in. The point is within like 10 minutes of turning on the exhaust, you could clear the entire room air, which means that we have a lot of exhaust in that room, which is the whole idea. Just like Brian, these sensors are ESP32s. They're live on the network. I've got fancy login capacity, so I can block everybody from actually screwing with them, though I'm not at the moment. Maybe I should.
Hear you sing louder.
Oh, he can hear me. He's listening to the audio from this. So the cool thing is in this case, this build, so this is coming from this website. So I haven't done any of this work. This, again, is not ChatGPT. This is other people writing up code. So you go on here, you wire up like 6 pins. Then you grab the flashing tool. I have to do some soldering. And they have this little tool that you grab. And you write the firmware to the ESP32. And then it turns up as a web server. And if you go to the web server page, you can configure what sensors you hooked up to it, just like Brian was talking about. And the only thing here is we're pushing right now to a live map that plots particulate measurements all over the place. And then this Madavi.de, some German website, is this charting site, which again, I'm assuming these guys are probably paying for a license to chart all these things to gather their data. This is created by a German university, so they have an interest in gathering particulate measurement data. But alternatively, we can publish our own data API, or like push it to a database somewhere locally. But the idea would be to make a little chart that shows the different sensors in the different rooms and whether or not we're like making a Martian level dust storm in a room, to quote another workshop down in Chicago called Pumping Station 1, who has various levels of like dust and debris in their rooms. So Martian storm is one of the options. But I'd like to do something like that at some point. And so if anybody's interested in helping with that, it's literally a matter of just grabbing the data either from here or from the sensor itself, and then presenting some type of a UI somewhere that is accessible so we can see what it does.
Do you want to get to Mars?
Well, Jeff nailed it earlier today, so I'm saying we were already there. Shira, not so quick on the draw. You're killing me here. I'm gonna change all the passwords. No, these are these things are not currently closed at all. So the setting is basically open, so anybody can change it around or whatever. The other interesting thing is these are all reprogrammable trivially, so it doesn't make any difference. I'm not worried about any of the stuff that's on here. Any questions quick about this stuff? Yeah.
The same dust that I'm experiencing. Do you run the fans continuously or do you cycle?
That is a very good question. So this sensor here runs continuously, but the ones that I put in the wood shop and the welding shop are a different one. They're a PMS 5003 versus this is a SH011, I think, or something like that. So these ones run all the time, regardless of whether they're sampling. The one in the wood shop and the welding shop I specifically picked because they don't run all the time. So it's only going to kick on the fan, draw a sample through, and then shut down and wait another 2 minutes, and then take another sample. So it's very.
Is it rated to run nonstop?
This one runs continuously, and it seems to be fine. I've had one running for like a year that way, and it hasn't had any problems. It's just running a little. It's a PC fan. So the little black thing on top is literally just a PC fan pulling air through the sampler.
Pretty good bearing.
Yeah, the actual limiting factor I think on these is going to be there's a laser inside. I bet the laser light source is going to die before anything else dies, or the intensity will reduce and you'll get bad data at some point. But these are also the other thing I should be clear on is that I've got like 6 of these. They're all uncalibrated. We could put them all in one spot and expose them to a fog machine or something to peg them to be doing something reasonable. We're not doing any of that. So all this stuff's like we're looking at relative amplitude. So did Jeff really hit 450 micrograms per cubic meter? Probably. But do we really care? No, we don't. We just want to know, like, based on no one in the room, where's it at? Based on lots of stuff going on, does it go higher, lower, or indifferent? One weird thing I had earlier that I did not expect was somebody went in the wood shop and started using the wood shop, and the air dirt level went down, which tells me that my in-room air cleaners are actually working because the particulate was floating in the air, and then when the fan started to stir all the air and pull it through filters, it cleaned the air. So it's actually a pretty cool thing to see that you actually we have cleaner room in the wood shop than we do outside. So that's an interesting thing. It just means we have good filtration and good dust extraction. But welding shop, not so much. What's that? These are powered over USB, so I just have them plugged into the wall. So I'm cheating. But yeah, to run this kind of stuff, battery powered. I mean, if you had a big battery and you felt like servicing them, I'm sure you can run them remotely. Again, the ESP32s can get shut down to a really low power state. So you'd shut off the fan, shut down the ESP32. And if you took a data sample like every 10 or 15 minutes, I would bet you could get something with a battery maybe yay big that would run for 6 months to a year. Sean actually has on a job site a time-lapse camera that has a big ass brick of like AA batteries. And that thing's supposed to run for a month or something, taking single frames every so many.
First 2 weeks I used it, it died because it's dropping. You can actually see the stop at night.
And it got cold. When you buy the cheapest batteries you can get, though, I mean, yeah. But at any rate, yeah, I think you could run one of these off a battery remotely by playing with it, but the code is not written to do that. It's very power intense.
Is anyone hooked up, or is there available radiation monitoring chip for these?
Yeah, you can actually. It is in here. There was a lot of interest when Fukushima got nuked. It might not be on this one. Nope. But there is in the firmware flashing config, you can do other things. Like this can know where it is with GPS. You do all sorts of temperature, pressure, humidity, particulate, light sensors, all sorts of stuff. Fundamentally, you can hook anything you want to it. It's just got to give this thing either a data stream and serial. Usually running SPI, SPI serial devices. So you could run whatever you want and then do it. Wouldn't be a big deal.
I mean, for the call up for web visualization.
Well, Dave's probably already got it written with ChatGPT, so I'm not really.
I was just gonna say, it doesn't.
No, you totally could. Ideally, someone who wants to work with my interns to show them how to do this would be spectacular. But somebody else can also do it. Sure, what you got?
So does the humidity, like the ambient humidity, affect the accuracy of the sensor? I know for the CO2 sensors, at above a certain humidity, they're, you know, considered to be affected.
Yeah, the particulate is literally looking at the particles going through a laser, like a laser, a whole, like a laser cavity, essentially, like a whole bunch of bounce back and forth with a laser and measuring occlusion. So I don't think that one's cross sensitive, but there's definitely, none of these sensors are very good. Like my background is in engine emissions. Like this is what I did for school. I did a lot of this stuff. We had a sensor that did the same kind of thing for particulate measurement. We had two different ones. Each of them were $20,000 a piece. They're created by a company that just does certified engine emissions. We could recreate that with these by having a whole shitload of them and then playing around with calibrations. But fundamentally, like this is, like I said, it's just a high, low, medium relative levels. I wouldn't look at the actual number very closely. But that said, if you have enough of these sampling, you can definitely nail in on they might all be wrong, but they're all going to hone in on some level of accuracy there. And the manufacturer is going to give us specs on the sensors as well, because these are used in like commercial products. Like that's why they exist. So it's just that they're not rising to the same level that the stuff that we had to use. But our box was like this big. Stuff was huge. So anything else? I just have one throwback. I'm sorry, sure, you won't be able to enjoy the throwback. It's actually if Brian's good on his Wi-Fi camera, you will. I have just one tiny bit of entertainment for y'all. Oh, very disappointing, Brian. I cleared the middle of my screen here with a nice black screen. I'm sure it's been ages since everybody's got this.
Oh, you got her working, huh?
But this is also from East High School, 1957. Stanley 35 millimeter film projector. So if you'd like to educate yourself on electric auger drill bits, you're welcome to flip through here. I don't know what Oh yeah,
Wait, there's no narration? Come on.
But I do have a funny one for you. Stick over to another. Sorry, we got a film strip here. It's just weird. This company, oddly enough, still exists. Just Knowledge Unlimited, which yeah, it's pretty wild. But quiz time. There's an essay at the end. I'll give you time to work on it. But
Carmen Sandiego.
perhaps a little too timely of a throwback here. But yeah, this was the newsreel from like 2001. Fun and entertaining throwback to life in 2001. It is fun to see.
Wait, before or after September?
This was before September, I think.
Oh, so
Yeah.
life was fun.
Yeah, this was life was still good. High times there. But yeah, so this was just a lot of fun to pull out of the bin. Was this the last year they were using? This was literally, I have no idea. The bulk of this is from '89. It's also halfway melted, so. But I did have to defeat the safeties on this, so this thing's running like no limits. There's a thermal fuse at the bottom of the bulb that had burned out. But if you grind the key off the bulb and flip it 180 degrees, you can stick it back in there. Yeah, it's working great. It's just a little bulb on the side.
Slightly modified?
It's just a little melted. The bulb has these giant like glass expansions on the sides of it that are not supposed to be there. But
Oh yeah, I saw it the other day.
These are fine. All right, Chris, who the hell are these people? I know the lower left guy, but who's the rest of them? Anybody know?
Oh, you know, number one is, she was the Florida election.
Oh, yeah, right.
Brian, you get a point. You got 1 point. Nice job. I don't know how the hell you remember that. The lower left dude is the FBI infiltrate the Russian mole. I think that's who that is. I have no idea who the other people are. But now it's time to write your essay questions. I hope y'all came with your pencil sharp. Yeah, so got a lot of this public now. But if you we got film strips, chisels for woodworking. So you know if you need your updates to get recertified. Get ready
You
to
got
go.
a lamp on for 3 minutes, so we're eating.
No, it's fine. I turned it off. The lamp's been awesome. The fan is still running because it's got to cool down. But at any rate, oh Scott, I think I bet I ran over your video because I still had Shira on. I'm sorry, Shira, you missed out on the 35 millimeter film, but
No, I actually kind of got a little bit of it from the high def camera.
it's not too exciting, but all right. I'm gonna kill off Zoom. So thank you for joining us. We'll see you soon.
Hi, Shira.